Hello folks, we come to the part 10 video of this exercise 1.1, and here we are going to take the problem number 11. It says that you are taking the set A, which is the set of all points in the plane, and R is a relation which is defined as all the points P, Q as ordered pairs such that their distance, that is the distance of P from the origin, is equal to the distance of Q from the origin. That is how the R relation is defined, to show that it's an equivalence relation. So basically, instead of so much of English, let's make it short. The meaning is OP equal to OQ. That is the distance of this point from the origin. Their distances will be equal. That means, suppose if we have a plane like this, and if we happen to choose 2 points P here and Q here, this OP, the distance OP will be equal to the distance OQ. And if such a thing happens, the points P and Q in ordered pair form will belong to R. That is the meaning of this particular thing. So that's about it. Let's show that it's an equivalence relation right away. First we'll start with reflexivity. Let or consider P comma P. Obviously OP is equal to OP, so P comma P will belong to R. So R is reflexive. Right. Then we have to go in for symmetricness. So let's talk about the symmetricity. Yeah, what happens here? Let P comma Q belong to R. What is the meaning? That OP equal to OQ, or in other words, OQ equal to OP. So Q comma P can belong to R. So thus, starting with P comma Q belonging to R, we are getting Q comma P belonging to R. So R is symmetric. Right. So that makes R symmetric. Now you check transitivity. So let's check how to do the transitivity part. Transitivity. Let P comma Q and Q comma S belong to R. What is the meaning? That OP equal to OQ and OQ equal to OS. Now you can have it connected together. OP equal to OQ, OQ equal to OS. So it means that OP equal to OQ equal to OS. In turn, OP equal to OS. If OP equal to OS, it means that P and S belongs to R. So starting with PQ and PQS belonging to R, we have got PS belonging to R. So R is transitive. And cumulatively from 1, 2 and 3, R is an equivalence relation. Right. Now, not only that, they have asked us something more in the question. They say that show that the set of all the points related to P is a circle that is passing through the origin. That means, suppose if you take a point P and you take all the points which are related to P, then they will form a circle. So it's like this. Suppose say we have a coordinate plane like this, and the origin. Suppose say this is P. Suppose I have a Q. Suppose I have a S. Suppose I have a T. Many, right? If OP, see everything, if PQ comma PS comma PT belongs to R. What is the meaning? It means that OP equal to OQ, OP equal to OS, OP equal to OT. So therefore it means that OP equal to OS equal to OT equal to OQ equal to some R. Right. So from a fixed point O, these points are at a fixed distance. That is the definition for a circle. That is why these points are on the circle. That is what is asked in the question. Thus, from fixed point O, points PQST are at fixed distance R. Therefore, these points are on a circle. Right? So that is what is asked, and that's what they have to prove. Now let's quickly go to the next question, question number 12, where they say that there is a relation R. I don't know what is the set A that they say show that the relation on a set of all triangles. So the set A is a set of all triangles where you define this R as T1 and T2. T1 related to T2, they are similar, right? So quite good property, quite easy to show. You have to show that it's an equivalence relation. So we start our journey like that only. Let us take the reflexive part. Reflexivity. Consider T1, T1. Obviously, every triangle is similar to itself. There is no harm in telling that. Therefore, T1 and T1 will definitely belong to R. There is no debate about it. So R is reflexive. Then we'll show symmetricness. Let T1 comma T2 belong to R. So it implies that T1 is similar to T2. Now, whenever a triangle, we know triangle similarity, it is like hardly anything if you just change the order. So T2 is similar to T1, we know, we have learned it in the 10th standard, in detail we have learned. So we know that T2 is similar to T1, that way we know that T2 and T1 can belong to R. So starting with T1, T2 belonging to R, we have got T2, T1 belonging to R, that is making R symmetric. Right, that's our 2. Now transitive. Let T1, T2 and T2, T3, let this belong to R. What is the meaning? T1 is similar to T2 and T2 is similar to T3. Now at length we have learned in the 10th standard that if you have one triangle similar to the other and the other triangle similar to the third one, automatically they all are going to be similar together. So there is no harm in telling that T1 is similar to T2 and similar to T3, which in turn means that T1 is similar to T3. So that way we'll have T1 and T3 belonging to R. So starting with this, starting with T1, T2 and T2, T3 belonging to R, we have T1, T3 belonging to R, making R transitive. Right, this is our equation 3. So from 1, 2 and 3, R is an equivalence relation. Right, we'll quickly see there's a part that is being given. Let's see what it means, what they want to say. There are 3 triangles, T1 which is made up of side 3, 4, 5, T2 is made up of side 5, 12, 13, T3 made up of side 6, 8, 10. Which triangles among T1, T2, T3 are related? So whether they are related. So here we have, this is triangle T1. This is triangle T2. T3. Now you are wondering why I have drawn it as a right triangle. They are right triangles because these sides, they are in triplet form. So if you check, they are all right triangles. So actually T1, T2, 3, T3, they are all right triangles, and 3 squared plus 4 squared equal to 5 squared in T1. 5 squared plus 12 squared equal to 13 squared in T2. Then 6 squared plus 8 squared equal to 10 squared in T3. So they are right triangled. right? They are right triangle. So the moment you show maybe either that you can have the A property or you have the SAS property or ASA, whatever the test that we have studied for similarity. If you could drop in any of those tests, then you are able to show that they are similar. So here now what will happen is in T1 and T3, if you carefully see, the sides are proportional. But T2, the sides are not proportional to either T1 or to T2. You can put all combinations and you can find out. So, but 3 by 4 is equal to 6 by 8. Just check. 3 by 4 equal to 6 by 8. 6 by 8 can reduce to 3 by 4. Therefore, T1 and T3 has sides proportional. Right. Therefore, T1 is similar to T3 by SAS test of similarity. Right. That's what they've asked. That which is related. Therefore, T1, T3 will belong to R. Whether they are related, that is what they are asking. So yes, T1 is related to T3 and they will belong to R. Right. That's all about this video. With similar 2 more problems, I think. Yeah, we have 2 more problems. We'll meet in the next video. Thank you.